Hello everyone, welcome to Zero to LLMOps. I am Abhijit and we are learning Linux at very foundational level for DevOps. And today is day 2. Yesterday we cracked open the boot process and systemd, how a Linux machine wakes up and who's in charge once it's running. Today we get fluent with the daily driver command line tools you will use every single day as an ops engineer, getting help moving around the file system, managing files, and the single biggest idea of the day input and output redirections. Everything you build for the rest of this course runs through these tools. Let's have a quick recall before we move on. This is how the day one sticks. What are the boot stages? From power on to the login prompt. So the five stages are UEFI, BIOS, where we perform power on self-test. Then is the bootloader, grep2. Then is the kernel and init ramfs. And finally the init or systemd, where PID1 is triggered. What is PID1? Process ID1 or PID1 is the very first user space program executed by the Linux or Unix kernel during the boot process. And all other processes are its child processes. And it's always the systemd. What does journalctl-b shows us? So journalctl-b shows us the logs from current boot session. If any of these felt shaky, that's fine. We are going to go over this for our entire course. So let's get our words straight first. The terminal is the window you are typing in. The shell is the program running inside it that actually reads and runs your commands. Ours is bash. The console is the physical screen. People use these words loosely, but now you know the difference. Every command has the same shape, the command itself, then options, then arguments. Options come in two flavors, short, one dash, and one letter, like -l, and long, two dashes, and a word, like all. Same many, different spelling. Now the single most important skill in this entire course, more important than memorizing any one command, is knowing how to ask for help. Because you will never memorize everything and you don't need to. Man opens the manual pages for a command and man is organized into numbered section. Section 1 is user commands, section 5 is file formats, section 8 is admin commands. So man pass WD shows you the command, but man 5 pass WD shows you the file format instead. Same word, different section, different answers. Help gives us a fast summary right in the terminal. Info is a deeper hyperlinked manual some commands prefer. Type or which tells you exactly what program runs when you type a name. And mine -k followed by a keyword called approps searches every manual page by subject for when you don't even know the command name yet. Let's see it over the terminal. Man-k directory head tells us 10 commands in which directory is involved. So ls is the command that we are using, find is a command that we will be seeing, and so on. Some of them we will see, some of them we won't see. Now let's see regarding type bash. So it tells us bash is usr bin bash. Basically, this program bash is actually a file usr bin bash. Now let's check which bash. It just prints the file name. It's one and the same. Now let's see how we can ask for help. ls -help pipe head. It tells us what all arguments we can use, and here we can also see the command option and arguments sequence in the usage section of it. So in Linux, everything is a file. Your documents, your devices, even live information straight from the kernel. And every file on the system hangs off one single tree, starting at slash, the root. Let's walk the map. Slash etc, system configuration. Every setting lives there. Slash where, data that changes and grows. Logs especially. Slash usr, most installed softwares. Slash opt, third party software. Our incremental project lives under here. Slash home and slash root, regular users. Files and the root user own home. Slash tmp, scratch space, can get wiped on reboot. And two special ones that tie straight back to yesterday. Slash proc and slash sys. These aren't real files sitting on a disk. They are the kernel showing you its own live state as file. Slash boot and slash dev you have already met. To move around that tree, you use path. An absolute path starts with slash. The full address works from anywhere. A relative path starts from wherever you currently are. For shortcuts you will use constantly. Dot is here. Dot is one level up. Tilde is always your home directory. And dash means the previous directory I was just in. Let's look and move around. So let's do ls-l slash. We can see all the files and folders that we talked about right now. Now, as we discussed, let's see regarding the process, the kernel telling us. Here we see the memory info of the machine, how much memory total, memory free, and memory available. Now let's move around to var log. Then let's do cd dash and let's see where we are. So we are again in home student. So again let's do cd dash and let's do pwd. We go into var log. Again cd dash. Let's go come to our home. Now the daily tools. First group. Looking around. PWD tells you where you are. CD moves you. LS lists. Learn its flags. Hyphen L for long detail. Hyphen A to show hidden files. Hyphen H for human readable sizes. Hyphen T to sort by time. Hyphen R to reverse. You will chain them. ls hyphen lath. File tells you what a thing actually is. And stat gives you deep detail, size, permission, exact timestamp. Second group, changing things. CP copies with hyphen R for whole folder and hyphen P to preserve the timestamp. MV moves or renames. Same command does both. mkdir-p builds a whole path of folder in one shot. Touch creates an empty file or just updates its timestamp if it already exists. ln makes links. A hard link is a second name for the exact same data on disk. A symbolic link is a pointer to a path. We'll compare what survives deleting the original in the lab. And rm deletes with hyphen r for folders. Use this with a caution. rm-rf deletes everything under a path and there is no recycle bin available for you to undo. Always remember and double check what you are pointing it at. So now let's move towards the demo. Let me clear my screen and let's do mkdir-p lab02 demo touch home lab02 demo a.txt ls-l home lab02 demo and here we see a file named a.txt is created on 23rd July. Now let's check the stats lab02 demo.txt a.txt and here we see all the details regarding the file. When was it first created? When was a change made to it? When was it modified? When was it accessed? And so on. And you will try for yourself on your systems and try to access the file with opening the file, editing the file, and observe for the changes. So, to read a file without opening an editor, cat dumps the whole thing to the screen. Less opens it in a pager. You can scroll and search, slash to search, and to the next match. Q to quit. Head and tail shows you just the top or bottom. And the star of the show, tail minus F, follows the file live as new lines get written. That's the ops engineer's heartbeat. You'll run it against logs every single day. WC gives us word count. It counts the lines, words, and characters. when you don't know where a file lives, two tools. Find searches live right now, walking the real tree by name, by type, by size, by modification time. And it can run a command on every result with -exec. Locate is faster because it reads a pre-built database, but that database can be stale and misses something you just created. Rule of thumb is find for the truth, locate for speed, but we are going to avoid it entirely. Now let's look at a demo of a find command. Find /etc hyphen name star dot conf mtime -30 head. So what did we get here? We got all the .conf files which reside under /etc. One of that file didn't wasn't permitted by our user to be listed, so it showed a permission denied error. But we got here the last files which were modified in last 30 days. So this is the heart of today. So slow down with me. Every program you run gets three streams and they are just numbers. Standard input number 0 where it reads from usually your keyboard. Standard output number 1 where normal results go, usually the screen. Standard error number 2 where error messages go, also the screen by default, but kept as a separate stream on purpose. Those numbers 0, 1, 2 are called descriptors. Now the power move. You can redirect any of these. A single greater than sends standard out into a file, but it wipes that file first. A greater than sign two times appends instead of wiping. Two and a greater than sign redirects only the errors. Two, a greater than sign ampersand 1 means send errors to wherever output is currently going. It merges the two streams. Ampersand and a greater than sign is shortcut for exactly that. A less than sign feeds a file in as a standard input or standard in. And dev null is the bit bucket. Anything you send there simply disappears, which is how you throw away output you don't want. Watch this split in action. ls/etc/non-existent out. So single redirection or greater than sign and then out.txt, then two greater than sign err.txt. What do you think will happen? Let's find out. Let's cat out.txt. So we got all the folders under /etc, all the files and folders under /etc in out.txt, and let's do cat err.txt. ls cannot access non-existent, no such file or directory. So this tells us that whatever the error was redirected to err.txt because we used two and a greater than sign, and whatever the output of ls command for /etc was, that was sent out to, or successful command was that was sent out to out.txt. So here there are two streams, but there are two separate destinations, and that was on purpose. Redirection, the redirection sends a stream to a file. A pipe, the vertical bar, sends the standard out, std out, of one command straight into the standard in, std in, of the next. That's the whole Unix philosophy. Small tools joined together to do something bigger. T is a special command. It splits a stream so you can watch it on screen and save it to a file at the same time. Then chaining commands. Semicolon runs the next command no matter what happens before. Double ampersand runs the next command only if the first one succeeded. Double pipe runs the next only if the first one failed. Success or failure comes from the exit code, which you can check with echo dollar question mark. Zero means success. This is the seed of scripting, which starts on day 3. And two things you'll feel the benefit of soon. Globbing. A star matches anything. So star dot. Log means every log file. And always quoting your variables, which we'll explain properly when scripting starts. let's run a real pipeline. Journalctl -b pipe grep -I error pipe wc-l. So what did this command give us? We used one line but three tools. Get this boots log with journalctl-b. Keep only the lines mentioning error and then finally count them with wc-l. That's the whole game. Now that's the theory part. Now we go hands-on for the next 2 hours. The full FHS expedition, file management drills, a redirection gauntlet, including a sneaky ordering trap with 2 greater than &1. And then we evolve yesterday's bootlogger.sh. So it writes proper split going files and automatically prunes itself to the last 5. Let's go. Let's go over the full FHS expedition. ls-l slash which. Let's look at man 5 OS release. Let's run which on bash, type on bash, file on bash. So few operating system have file command, mine doesn't. And then stat on bash. We will need to give the whole path for stat command of the file. So here we see its birth time, its change time, its modified time, and its access time. Birth and change are same, but others are different. Now let's look at proc CPU info, and here we see the information regarding our CPU. How much megahertz, who is the maker, what are the flags, what are the address sizes, and as we looked in the lab in the demo, proc meminfo. It gives the memory information. We looked at first 3 lines, but then there are buffer, cache, swap, how much is active, how much is inactive, what is the kernel stack consuming. So all the detailed information. Now let's try to build parent folders, and here let's look at how to use the shortcuts, the curly braces. So let's do mkdir-p home lab02. Let's open a curly brace, projects, alpha, beta. Let's close the curly brace, archive, scratch. Let's again close the curly brace and let's see. So let's go to lab02. Let's see here. We have alpha, we have projects, and in projects we have alpha, beta. So remember this thing. In alpha, we don't have anything. In beta, we don't have anything. Now let's come out and let's go to archive. So see the pattern here. We had lab02. In that, we created projects. In projects, we wanted alpha, beta. And outside in lab02 only, we needed alpha and scratch. So at the same time, we were able to create this folder structure. We will look at tree command structure in detail, but this is how it looks like. You can also install and use tree. Now let's do cp lab02 demo a.txt to lab02 projects alpha. What has happened is in lab02 projects alpha, we are able to see a.txt, ls-l, a.txt, and ls-l home lab02 demo a.txt. You can see the file permissions are of the student, the creation time. So this was created at 10:39 and this is created at 10:58. So what we see here is the time has changed. But however, let's do cp-p and you need to take a look at help and man pages to see actually what -p does. But for now, let me demo you and let's copy it to lab02 beta projects beta folder and let's do ls-l a.txt in beta folder. ls-l in beta folder shows us the file was created at 10:39, which is exactly when the file was created. So -p what it does, it copies with its timestamp and its permissions. One task that I would like you to do is go to root and the root user I am talking about. Go to root and try to copy and see how this owners and group change. So that's the application. If you want to keep the owner and group and the attributes of the file, that is time, same, then you use cp-p. Now let's look at mv command. So mv a.txt, as we are in alpha, let's do b.txt. What it does is it has renamed the file as b.txt. Did it change any timestamp? No. What is the current time? It's 11:01. But here you see the timestamp of file is 10:58. Now let's safely remove this file b.txt. Now let's look at what is hard link versus symlink. If I do simply ln command, link command with lab02demo a.txt, and here what I see is I get a a.txt that is the same as this a.txt. How can I prove that? Let's do echo my first file to a.txt, which is here in alpha. Let's cat both the files. Lab02 projects alpha a.txt, my first file, and cat home lab02 demo a.txt, my first file. So we wrote in the alpha in projects under projects to the a.txt, but it got replicated to lab02 demo as well. Let's do a simple ls-l for both the files as well and check out the modified timestamps. You see, those are same. Now, let's move towards soft link. This is called as hard link. Now, let's create a soft link. Let's move to beta folder. And in beta folder, let's create a soft link of b.txt for the a.txt from lab02 demo file folder b.txt. How do you determine whether it's a soft link? You see a text, then an arrow pointing to the original file. Now, if I try to do some echo, my second line, and let's use double redirection here so that we append instead of overwriting b.txt, and let's see b.txt, my first file and my second line, and let's do a cat on a.txt. So whenever we wrote to the soft link as well, it is one and the same that we have written to a.txt. Now let's do one thing. Let's try to see, figure out what happens if we remove the original file to which we have created a hard link as well as a soft link. So we remove the lab02 demo a.txt. Let's check ls-l, no such file or directory. Let's do ls-l b.txt and cat b.txt. So when we do a cat b.txt, we saw the same error which we are seeing when we do a ls-l on the original file. Now this system has colors, so we can see it is highlighted by color, but sometimes you won't see this thing. But now let's go to the alpha folder because we had created a soft link there. The file is present a.txt and the contents are present as well. So the hard link survives. That means the file is exactly the same. Now let's copy this a.txt to the original location and let's again go to beta. Here again we see that the link has reappeared cadb.txt and the file is also same. So remember, this is soft link. And what will happen if we remove b.txt from here? So from this folder, the file went. Let's check the original location. The original file survives. So this is called as symlink or soft link, which we did for b.txt. Now let's take a look at redirection gauntlet. So let's write echo how are you. This is a single command, and let's on the completion of this, let's do wc-l on a.txt and then do ls-l b.txt. So if we run this as is without the redirection, let's see what happens. Let's do one more thing. Let's redirect the output to out.txt or let's say out.log, and let's use this append method so that it goes to that thing. We will also look at T command, but right now let's use the output redirection. So what do you think will happen? What will out.txt, out.log hold? Let's say it. And on the terminal, what we saw is how are you 0 a.txt and ls cannot access b.txt, no such file or directory. What this ampersand tells us, it tells us run next command only if the previous command was successful. And let's look at out.log. Nothing got redirected to out.log. Why? Because we need to use the output redirection. So what we'll do, error ampersand 1. Now let's look at out.txt. What happened is the error got redirected to out.log. So here we saw how to redirect errors to output file. Let's see how much word count does etc pass WDA has with input redirection. Now let me do a tail-f on where log messages. Oh, we need root here. What I will do for a demo purpose, I will log in from another terminal, and here you saw how the log shows. Now let me log out, and hence we are seeing the continuous logging. Same thing you can do with journalctl-f as well. Now let's evolve our freshers project bootloader.sh cd opt freshers project. Let's do it with the redirection. So now to do the incremental project, we'll create a logs folder mkdir-p opt fresher project logs. Now what bootloader.sh has, let's run it and see. So it shows the errors, recent boot errors, slowest 5 units, the host name. Now as we are building incrementally, we'll use the previous elements along with, and now let's run bootloader.sh a couple times. Let's go to the logs folder and see here we have boot 2026 logs which has the entries. Let me again get it, and it has all our logs from our learns, and boot error logs just has the error logs. So I will paste this snippet in the description below. Here we have split the errors in error log using to and double redirection. We have used t-a to show us the normal log, and we have redirected it to the normal log. Now let's do the recap and move towards the homework. For getting help, man and its number sections -help and man-k is a skill that outlasts every single tool. Everything is a file, one tree from root, and now you can navigate it with absolute and relative path. You can inspect, copy, move, delete, and link files with real confidence. And the big one, every process has three streams, in, out, error, and you can redirect or pipe any of them exactly where you want. Homework, finish today's lab tree if you didn't in the class, and run bootloader.sh twice, confirming with tail wc-l, and find logs minus mtime -1. That split logging and the keep last file cleanup both worked. Three questions. What are the file descriptors 0, 1, and 2? And what does 2 greater than ampersand 1 literally do? Why does 2 ampersand and 2 greater than ampersand 1 file behaves differently from file 2 greater than ampersand 1? And when would you reach for find instead of locate? Tomorrow is day 3. User groups, permissions, and sudo. Who's actually allowed to touch all the files you just learned to manage?